Okay, so this is an intro to linear functions, which you guys know a lot about from Algebra 1. But in the next few lessons, we're going to be learning about systems of linear equations. So this is a pretty good intro just to remind ourselves about linear equations. So linear equations are often written in standard form, which is ax plus by equals c. And that form doesn't really tell us much. So for example, slope-intercept form tells us the slope and the intercept. Point-slope form tells us the point and the slope. This form doesn't really tell us much, but a lot of times you will see equations given in standard form. So if we look at number 1, what we're looking for is for the first term to be positive because it says a is greater than 1. And the GCF of A, B, and C is 1. So for question number 1, we want the first term to be positive. We want x and y terms to be added to each other on the left side and the constant to be on the right side. So in number 1, the only problem with this is not that the x and the y are in the incorrect place, it's that the first term is negative. So what we're going to do is divide every term by -1. Because if you do it to one side and you do it to the other side, then you're okay. So -5x divided by -1 gives us 5x minus 6y equals 12. That's standard form. In number 2, this isn't necessarily in standard form. It's actually in slope-intercept form, which is y equals mx plus b. So we need to get the x and the y terms on the same side with the constant on the right side, and then worry about making a greater than 1, or in other words, positive. So let's first get the x term on the left side, and that would look something like y minus 2x equals -9. We do want x to come first, so we'll write it as -2x plus y equals -9 using the commutative property. And then again, divide every term by -1 so that the first term is positive. We always want the first term to be positive. So all of the signs change, and that's okay. Okay, for number 3, we want to get x and y on the same side. They actually are on the same side, but there's also the -24, and we don't want that on the left side. So we're just going to add 24 sides. So we get 9x plus 6y equals 24. Now, if you go back to the description of standard form, it says where a, b, and c are integers, which is true right now, and a is greater than 1, which is also true, and the GCF of a, b, and c is 1. And what they mean by that is that there is no common factor in every term, but the GCF between these 3 terms is not 1. There's actually a GCF of 3. So we're going to divide every term by 3, and we'll be left with 3x plus 2y equals 8, rather than having a common factor between all of them. Okay, I'm going to leave number 4 for you to do on your own. And I'm going to check this packet. So make sure that you complete this one on your own. Okay. And number 5, this is kind of a special case. So I'm going to do this one for you. First of all, we want a to be greater than 1. And not only does that mean that it's not negative, but it also means that it's not a fraction. So in order to clear the fraction, we're going to multiply by the least common denominator between the 2 fractions, which would be 12. And just watch what happens when we do that. So what happens is 4 goes into 12 3 times, and we end up with 9x. 3 goes into 12 4 times, and we end up with 4y equals 12. So when you multiply by the denominator, it cancels out. We multiplied by 4 times 3, which is 12, so that both denominators would cancel out. And that's all you had to do there to get it into standard form. Okay, I'm also going to let you try this one on your own and make sure that you complete so you get a full grade on the packet. Okay, so slope-intercept form is what we all know a lot about linear functions. We always know about slope-intercept form. Linear equations are often written in slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Slope is the constant rate of change between the points. We know it as rise over run. There are 4 types of slopes. So this is kind of important as we go forward in Algebra 2, constant rate of change, because rate of change can be any function. Everything has a rate of change. Everything changes and it has a rate that it changes at. Lines have constant rate of change, which means that they change at the same rate throughout the entire function, and that's what makes it a line, and that's why we call it a slope rather than just rate of change. It's a special type of rate of change. So there's 4 types of slope, and we're going to draw those. So I would draw an XY axis. Whoa. We don't want that. Okay, so draw a little XY axis, not like that, in each of these boxes to give yourself an example of what the slopes are going to look like. Nothing special, just a normal XY axis. So we have a positive slope, which is an increasing line, which we talked about when we talked about increasing intervals. We have a negative slope, which has a decreasing interval throughout the entire line. We have a 0 slope, a line that has a slope of 0, which looks like this, which is a horizontal line. And then we also have a slope of undefined. An undefined line is a vertical line. So if you know that, great. If you don't, there's actually a little trick that I'm going to show you. So you might want to leave your notes just like that if that makes sense to you. But if you need a little trick to help out, negative lines make the inside of an N. So that inner part of the N right here has a negative slope in it. So it reminds myself that N negative, the inside of the N makes a negative slope. Now the same thing kind of applies to 0. It's the top of a Z. So the shape that the top of the Z makes, a horizontal line, reminds me that there's a 0 slope. And it actually works for undefined as well, because this is the hook, the side of the U for undefined. And then positive, I think we all know what positive lines look like, but if we don't, we'll have to come up with a trick for that one. I mean, you could probably do a sideways P, but you could probably do that on all of the lines. But if it helps, it helps.